All right, let's have a look at a stoichiometry problem. This stoichiometry problem says when aqueous solutions of sodium sulfate and lead-2 nitrate are mixed, lead-2 sulfate precipitates, calculate the mass of lead-2 sulfate formed when 1.25 liters of 0.0500 molar lead-2 nitrate are reacted with excess sodium sulfate. So we know that for any stoichiometry problem, our first step is to write and balance the equation. For this one, the equation is already written, but we need to balance it, and I think we'll check and see that it needs to be balanced. If you'd like, you can pause the video at this point and balance it yourself. Okay, so to balance this equation, we're going to put a 2 out in front of the sodium sulfate, and that should take care of all the balancing. All right, so the next step in one of these problems is to change what we're given into moles, and what we're given is 1.25 liters of 0.0500 molarity, and that's lead-2 nitrate. Now we can look at this a couple of ways. We can look at this from a purely mathematical standpoint. If it's got an of in between two numbers, we know that we're going to multiply them together. Let's just do it that way and see what happens. We take 1.25 liters times 0.05. I'm going to leave those zeros off there. But big M means moles per liter. So if we multiply these together, look what happens to the units. The liters on the top and on the bottom will cancel out, and we end up in moles, and that's what we want anyway. So that worked out pretty well. And when you multiply those out, you're going to find this 0.0625 moles, and I'm going to write down that that is of lead-2 nitrate so I can keep track of where I am. Right, so we've written and balanced the equation. We have then changed the given into mole just by using math here. You could also use the definition of molarity to do that as well. So the next step will be to then take that number, 0.0625 moles of lead-2 nitrate, and we need to change substances by using the mole ratio from the balanced equation. In this problem, we are looking to find the mass of lead-2 sulfate. So I go to the balanced equation and I look and I see that there's a 1 right here in front of lead-2 sulfate, so that's 1 mole of that. And on the bottom goes what the substance that we're coming from, which is this one. So the number in front of that is also 1, so it's 1 mole of PbNO3 in parentheses 2. So doing that step was essentially not doing much of anything. The moles of lead-2 nitrate cancel out the moles of lead-2 nitrate. It's times 1 is going to be, or 1 divided by 1.0625 moles of PbSO4. All right, so we have written and balanced an equation. We have changed the given stuff into moles. We've used the mole ratio. The final thing to do is to find what we're looking for. And it says to calculate the mass of lead-2 sulfate formed. So I have moles, so I'm then going to use the molar mass. And so on the bottom of this will be 1 mole and lead-2 sulfate. And on the top is going to go the molar mass. Now I took the time to add that up ahead of time, so if you want to pause now and go and add up 1 lead, 1 sulfur, and 4 oxygens, you can certainly do that. So I'll pause for a second if you want to do that. But when you add that up, you're going to find it's 303.3 grams of lead-2 sulfate. So again, the units are going to cancel out here, here, and this will come out to be, when we round it to 3 significant figures, 19.0 grams of lead-2 sulfate. So I would suggest going back and looking at the steps and following through each one of the steps in that problem to see why we did what we did.